Hi everyone, good day. Are you ready for another Math Venture with Teacher Rev? Let's start our statistics learning journey.
Okay, this time, let's tally the scores. Let's do it per row. The row score is on the left side. Let's look at the left side. So we have 38, 32, 28, 20, 50, and 17. Let's tally that first. We know that 28 can be found here from the class interval 27 to 32. So let's tally a mark, 1 mark. 32 is also here. 28 is here. Where's 28? Oh, also here. Then 20 would be here on the third class. 50 would be on the last class. And 17 would be on the third class again. So for us to be able to understand this very well, let's mark those things that we identified as red. But this one, we have not done this. So let's mark it back first. Okay. Now let's try the second row. This time let's tally 21. The second row, that means 21 is from 21 to 26. That is in the fourth class interval. Then we have 13, which is on the second class interval. Then we have 39 on the second to the last class interval. 10 on the second class interval. 18 on the third class interval. And 41, which is on the second to the last class interval. If we do this, we'll have something like this. So if we continue tallying, we're going to have something like this. This time, after we tally, let's identify the frequency. So in this case, let's use blue. And we have frequency is 1. Here it's 7. Here it's 8. Here it's 4. And then we have 11. Here it's 8. The second to the last class will have a frequency of 7. And the last class will have a frequency of 4. Now, given this, the total of this will be 50. This is actually the number frequency. That means for the class intervals 9 to 15, 9 to 14, there are 7 scores, which scores from 9 to 14. From 45 to 50, there are 4 scores who have a score of 45 to 50. Since this is already a range of values, that's why we call it as group frequency distribution. Now let's look at the class mark. We're not yet done with our frequency distribution table because to be able to form a frequency distribution table, we need our class mark, our frequency, and our class. We need our class interval, our frequency, and the class mark. Now, how do we get the class mark? The class mark is also known as the midpoint, which is often referred to as X. Note that, let's go back to the class interval. In the class interval, you have 3, 9, 15, 21, 27 on the first side. 3 to 8, 9 to 14, 15 to 20. So meaning every class interval has a lower value and the lowest value and the highest value for every class interval. In this case, the 3, which is the lower lower value in the class interval, we call it as the lower limit, or we call it as LL. The 8, on the other hand, which is the highest value in a class interval, is what we call the upper limit, or it is often referred to as UL. Therefore, the lower limits are 3, 9, 15, 21, 27, 33, 39, and 45. And the upper limits are 8, 14, 20, 26, 32, 38, 44, and 50. Now, why is this important? Because when we identify the class mark, we simply get the average of the two numbers. When we say average of the upper limit and the lower limit, since it's the midpoint, we divide it with 2 since we're adding the two numbers. Now, in that case, that would mean the class mark on this case would be getting the average of the lower limit plus the upper limit divided with 2. Therefore, the class mark here is 3 plus 8 divided with 2. And the answer is 5.5. So the class mark or the midpoint of the class interval 3 to 8 is 5.5. Now, is it the same with others? Yes, we use the same formula for the others. That would mean the class mark for this case would be 9 plus 14 divided by 2. That will be equal to 11.5. Same case here. That would be the class interval 15 to 20 would be 15 plus 20 divided by 2, that's 35 divided by 2 is 17.5. Let's continue. 21 plus 26, that would be 47 divided by 2 is 23.5. Now, we can continue this pattern, but I want you to discover something else. We know that the class read is 6, but let's take a look at this. What's the difference between 5.5 and 11.5? If your answer is 6, then you're correct. Exactly, that's 6. How about 17.5 and 11.5? The difference is also 6. How about 23.5 and 17.5? Exactly, the difference also is 6. Now, we expect that the difference of this is 6, so adding 6 with 23.5, we have 29.5. If we add 6, is this also true when we get the average of 27 plus 32? Yes, it's also true because when you add 27 plus 32, that will be 59 divided by 2 is 29.5. So, you can actually play a lot with the values that we have in a frequency distribution, but we're not yet finished. So for us to be able to create the group frequency distribution, what do we need? We need a class interval. We know how to get that. We know that the class read is 6. We acquired that with getting the range divided by the number of classes. The number of classes, we decided for it to be 8. The midpoint, on the other hand, is the average of the upper limit plus the lower limit divided with average, so we divided with 2. Now, the class boundary. Notice that when we have 3 to 8 and 9 to 14, there's actually a gap of one unit from 8 to 9, correct? That means the gap would be 1. We need to get halfway of that, so we divided with 2, so it's 0.5. That means to put remedy on the gap, to get the class boundary, we subtract 0.5 from the lower limit and we add 0.5 from the upper limit. That means the class boundaries would be 3 lower limit minus 0.5 would be 2.5 and the upper limit would be 8 plus 0.5 would be 8.5. That's for the first class interval. Let's go to the second class interval. We need to do the same. So it's 9 minus 0.5 is 8.5 until 14. The upper limit plus 0.5 is 14.5. So let's continue with the third class interval. The lower limit is 15, so that would be 15 minus 0.5, that's 14.5, until 20. When we say 20, that would be plus 0.5, 20.5. Notice that we end with 8.5, but we start with 8.5 on the second class boundary so that there will be no gap. This is for the boundary, not for the class interval. Now, in the boundary, there's a lower value and an upper value. Again, how do we get that? By adding 0.5. Where did we get the 0.5? Between 8 and 9, there's a gap of 1. We get halfway of it, so we divide it with 2. The answer is 0.5. We subtracted 0.5 from the lower limit, but we added 0.5 from the upper limit. That gives us this idea. So you know that even if we don't look at the first class interval, we know that if this is 20.5, we'll start with 20.5 here until 26.5, and so on and so forth. So that's how we acquire the class boundary. If we continue doing that, we'll have the class boundary here. Now, this is group frequency distribution. So I'll continue. Okay, let me continue. 26.5 to 32.5, 32.5 to 38.5, 38.5 to 44.5, and then 44.5 to 50.5. That's it. These are the class boundary. Later, you'll know why we need to create a table, because this table will be presented to a graph, to a beautiful graph on the next videos that we're going to discuss. So let's continue. This time, that's it about group frequency distribution. What do we need? We need to have the row column headers of class interval, frequency, midpoint, class boundary. This completes the table of the group frequency distribution for the test scores of 50 students in statistics test. Now, we don't only have frequency distribution. We have other frequency distribution, such as relative frequency distribution. When we say relative frequency distribution, remove the R there, it's a table that lists the relative frequencies of the classes. What do we mean by relative frequency? The relative frequency is obtained by what? Dividing the class frequency. By what? By the total frequency. This time we're going to need our calculator. How do we get the relative frequency? It's very clear. We divide the class frequency to the total frequency. In this case, the class interval 3, 8 have a frequency of 1. Therefore, we get the relative frequency by dividing 1 by the total frequency 50. And the answer is, we click that on our calculator, divided by 50. The answer is 1 over 50. Click on SD to make it decimal, 0.02. We do it for the rest of the item. Same thing. 7. For the second class interval, we have 7 divided by 50. So we have 7. I just change this and equals, not plus, divide. Okay, equals 7 over 50. Click on SD, 0.14. This time let's have 8. Okay, because the third class interval have a frequency of 8. 8 divided by 50, that will give us 4 over 25 or 0.16. So this is 8 over 50 or 0.16. And 4, let's have 4 divided by 50 is 2 over 25 or 0.08. 0.08. Next, we have 11. 11 divided with 50. That will give us 11 over 50 or 0.22. So I will not repeat 8 anymore because I have it here already. That's 0.16. Same as 7, I have there already. That's 0.14. Same as 4, I have it here already. That's 0.08. Now, these are the relative frequencies. Where do we use this? Again, we're going to use this in graphing, which will be shown in the next videos. Okay, now let's check on the values. What if we add all these values in the relative frequency? What will it be equal to? So now we have the relative frequencies. This time, let's identify the sum of the relative frequencies. Let's add all these values. We have 0.02. Let's use our calculator. 0.02 plus 0.14 plus 0.16 plus 0.08 plus 0.22 plus 0.16 plus 0.14 plus 0.08. And the result is 1. Exactly, the relative frequency is 1. Okay. Now, where do we use this? So, when we are doing the relative frequency distribution for the test scores of 50 students or any relative frequency that we are going to construct, the relative frequency distribution, what do we need in our table? We need the class interval, we need the frequency, the midpoint or the class mark, and the relative frequency. Once you have these 4 items, then it is already complete. You already have your relative frequency distribution. But how do we graph this? When we graph this, we need to add another column which talks about the percentage frequency. Now, when we say percentage frequency, we're going to have the relative frequency in percent. Multiplying it with 100, we have 2%, 14%, 16%, 8%, and so on. And the total would be 100%. These are the labels that we're going to use when we are going to graph a relative frequency distribution.
This had been a great learning adventure. So, see you next time on another Math Venture with Teacher Rev. Remember, don't stop until you're proud. Learning math takes time. Bye!
And I can't wait so we can break